Section 7.1, Radical Functions. In this first example, they're asking us to identify the radicand, find the indicated values, and the domain. The radicand is always the quantity underneath the radical, so our radicand would be x. Next, they're asking us to evaluate this function when, in the first case, x is equal to 0, so the square root of 0 only has one solution. Only 0 times 0 would give us 0. The next example, they're asking us to evaluate the function when x is equal to 4, so we'll take the square root of 4. We're looking for the principal square root, in other words, a non-negative solution. What times itself gives us 4, and that would be equal to 2. The last part of this is to indicate what the domain is. We have restrictions on the domain when the variable is in the denominator or underneath a radical, and that is the case here. We can only take square roots of non-negative numbers, so our domain, in other words, the value of x, has to be greater than or equal to 0. If it's a negative, then we can't have a solution in the real number system. As I said in an earlier video, we will cover this topic when we discuss complex number system, but for right now we're going to stay in the real number system. This would be our domain, and if we're listing this in interval notation, we're talking about the values at 0, including 0, and continuing infinitely towards positive infinity. So interval notation, we start with our smallest value, including it with the brace, and going towards positive infinity. In this next example, same thing. They're asking us to identify the radicand. The radicand is the quantity underneath the radical, so we would specify x minus 5. Next, they want us to evaluate this function at these values. So we will replace x with 13 and simplify. The cube root of 13 minus 5 would leave us with 8, and the cube root of 8, looking for a number times itself 3 times. Since 2 to the third power is equal to 8, the cube root of 8 would be 2. Evaluating the function when x is a negative 3, we will replace x with a negative 3 and the minus 5. Minus 3 plus a negative 5 is giving us the cube root of negative 8. The cube root of a negative number is negative. There is only one solution. Just like the cube root of a positive, there's only one solution. What number times itself gives us negative 8? It would be negative 2. Negative 2 times itself, or 3 times, or 2 to the third power, gives us negative 8, so the cube root of negative 8 is negative 2. Domain-wise, as we've just seen, we can take the cube root of a positive number. We can take the cube root of a negative number. When you are taking an odd root, and we are, our index of 3 here is odd, we can take odd roots of positive and negative numbers, so there is no restriction concerns on our domain. The domain in this case then will be all real numbers, and in terms of interval notation, we are going negative infinity to positive infinity. In this next example, we're given a function g of x is equal to the 4th root of x plus 2. They're asking us to identify the radicand. That's the quantity underneath the radical sign regardless of the index, so it would be an x plus 2. Evaluating this function, and these really should be g of x's, g of 14, replacing x with a 14, will give us a 14 plus 2. They're asking us then for the fourth root of 16, which is what number times itself gives us 16 4 times. Well, 2 times 2 is 4 times 2 is 8 times 2 is 16. So the fourth root of 16 would be positive 2. A negative 2 times itself 4 times would also give us 16. But when we're dealing with an even index, and by index it's the root here, the fourth root, we always want a non-negative root. Since it's an integer, we don't need to worry about our absolute value signs. Evaluating further, g of negative 3, we will replace x with negative 3. Adding, we have a negative 3 plus 2, simplifying to a negative 1. And given this is an even index, we cannot take the root of a non-negative number. This does not exist. There is no number times itself, the same number, that would give us a negative 1 number when we have 4 of that same number. 4 negatives would make a positive. 4 positive numbers multiplied would give us a positive. We are not going to generate that negative 1. In terms of a root then, this falls under the category of that even index, similar to what we saw with square roots. We can only take even indices of non-negative numbers. So our domain does have a restriction. The radicand must be greater than or equal to 0 for us to simplify that. And we saw 2 examples, not conclusive, but some examples of what that looks like. Fourth root of 16 did exist, but the fourth root of a negative number, in this case negative 1, did not exist. So for the domain, x plus 2 has to be greater than 0, and solving for the variable, we'll subtract a 2 from each side. X has to be greater than or equal to negative 2. Interval notation, we are including the negative 2, our smallest number, and increasing towards positive infinity, which we end with the parenthesis.